guess, yeah, let's kick it off as Ben said, right? So first of all, thank you, Ben, and the entire New Jersey, VMUG community for having us today. I think this is it's going to be a good topic. I think, in a segue into, I think, what you guys were just talking about. So, the topic is going to be the infrastructure as a code, right? Great way to kind of transition from what you do as your traditional, virtual infrastructure admin, into your SRE mindset, right? So myself, Chirag Patel, the principal architect within VMware Professional Services. We've been with VMware for 15 years, been involved with a lot of, large projects, and what we're going to talk about here, what Joseph was talking about earlier, so to speak, aligns to, I think, some of the content we have today, right? So we'll talk about the overall thinking behind this, and Selva has a great content to walk us through how do we do this, right, from a tooling point of view, because there are many various ways to kind of achieve this goal. We just wanted to make it real for you guys using a tool, but as we cover the tooling aspects, you guys will see that there are probably many many options that you have, and we definitely want to make it interactive as much as possible, right? So Ben and others feel free to chime in and direct the conversation the way we need to kind of take it. So that's about me. Selva, you want to introduce yourself?
Yeah, sure. Thanks, Chirag. So hi, this is Selva Jagnathan, and I'm with the industry working on the VMware technologies for like more than 20 plus years. Mostly worked on the Wall Street firms, and so with VMware, I'm with VMware for like 7 years, more than 7 years. And so mainly focused on integration and automation, on realized automation and automating all the vSphere component, NSX, and other like multi-cloud scenarios. And also working on the map view, like mainly on the modern applications, on the cloud native apps. So I'm part of the CTV ambassador team and also HL captain. So I have the Tensor Kubernetes grid from the last VMworld presented for the HL Export Lab, and this year working on the same Tensor Lab and Tensor Advanced Services and other Tensor products. So this coming up in this VMworld, I'm presenting those. Moving on, and so today's section, it's a huge list, but I'm going to condense it very simple and easier for everyone to digest. It's mainly we'll cover the infrastructure as a code, and we'll go into deep dive into the Terraform, and then we go into the main related to the vSphere or NSX providers. And then finally we jump into the troubleshooting scenarios, and we'll explain about the hands-on lab. So here the infrastructure as a code, what's the exact challenge, right? So let's start out by discussing the devious challenge about DevOps, and I'm not going to go too deep into DevOps, right? So there are obviously plenty of discussions out there can be had, but it's important to touch on a little bit here for context, so that which simplifies the development, often complicates the operations. And so what do I mean by that? Is of course, like when developers have access to create the infrastructures using like tool like Terraform, for instance, right? So they are going to create a lot of it, and they are going to create it often and without any checks and balances, right? So they are often like going to oversize their requests. They're going to leave unused infrastructure in the environment. So it's going to show up the on-prem resources, or worst, it's going to show up like cloud resources, which are considerably like more expensive, right? So obviously this isn't failing with developers or with the system that is there, or even with the Terraform. So it's just the restriction of resources that isn't there, right? And it leaves the operation to try to find out the ways to restrict those resources. And to do that, so the operation has to go through there and either use considerable manpower to police everyone's activities on that, or to reach out to people to find out like if there is any using infrastructure that's out in the cloud, or you know how to reclamation or right sizing and things like that, right? So it's really lots of overhead for operations to manage it. So the common challenge that we are here to see, developers want to use tools like Terraform, but operations would obviously prefer that you use some kind of like a management to dictate or the life cycle of all those requests. So to make sure like it's all automated and managed in the timely fashion, right? So that's the main idea here. And so why infrastructure as a code? So let's stop for a second and try to nail it down. Why infrastructure as a code is really today's development tool. So in recent years, we have seen an increase in need for on-demand infrastructure to accelerate business development, the move to more agile development, and IT shops have just driven new challenges in operations and in the development. And it's also driven rampant resource usage, higher costs, and even outages when resource demands exceeding the capacity. So even in most recent years, like we are starting to see a new shift that allowing developers to request the resources as the part of their daily code using APIs, CLIs, or tools like Ansible, Puppet, SaltStack, or Terraform, and things like that. So because of this kind of a new shift, what we are probably already using something like Chef or Puppet or Terraform in your environment in order to satisfy the demand, right? So there's the various tools we can use it that to manipulate or manage your own infrastructure. Yep.
So I think one thing, Selva, before we double click on this one, right? Just on this slide, I mean, the reason I think we have a lot of things on this one, right? And would love to kind of take some feedback from all of you as well. Feel free to put it on a chat in terms of what do you use today in your day-to-day work will be great, info for us. We can probably tailor some of the conversation, subsequent conversation to that. But the idea, right, here is that if you look at the concourse, right, I mean, it is typically it's leverage as a pipeline, based continuous integration approach, right? To deploy, your external state, so to speak. If you look at kind of Terraform, right, you have your Terraform, template, or you build the configuration files, the programmatic, way to define your target state, right? Using various Terraforms in a method. If you look at kind of Ansible, right, you can potentially do a lot of similar things with it, but the way you go about doing it, right, it kind of varies. And with Ansible, you end up kind of defining your playbooks, and you kind of interact with purpose-built modules, right? And you can execute your task to deploy your infrastructure components, and you can probably define the target state, and if it changes, right, you can kind of replay those playbooks as well. The VRO that you see here on the top, if you guys are not familiar with it, hopefully you are, but that is essentially the VMware orchestrator that can not only has some native capabilities to help you automate some of the VMware infrastructure, but it also has actually good integrations to other components, right? With with the rest of the ecosystem to go achieve what you want to achieve. So we are typically not married to single tool. The most customers that Selva and I kind of go to, each customer to customer, it varies. Even within customer, actually, there are probably many different teams that leverage different tools also. So we end up working with a lot of these, even on a single customer, right? But despite all of that, right, the end goal is to transition. As Ben kind of alluded to, anything that you do, twice, you should be kind of thinking about, automating it. And, the whole tooling side actually has kind of evolved, quite a bit, right? I mean, each player that you see here, each logo that you see here, are doing, quite a bit of work independently with the, rest of the industry, and also with VMware, right? So VMware also, sees this as a way to kind of, proceed further, right? So, a lot of the, since we are going to talk about the Terraform specifically today, in terms of how do you go about doing this, a lot of VMware solutions, right, has a built-in Terraform providers also, so you can start doing this, right? If you were to, including the infrastructure side, vCenter NSX is something we're going to double click on today. Selva has a great demo for you guys as well, so we'll see it in action exactly how it works. But even VRA, for example, right, which is more of a customer-focused tool. Even that one, a lot of our customers are kind of leveraging Terraform approach to go simplify the consumption and go build the infrastructure as well as manage the infrastructure as well as consume the infrastructure, right? So all of these tools, the point is pick your poison, pick what works best for you, but get on this journey, I guess, right? And I think some of the message that Joseph was talking about is spot on as well. So with that, I guess let's move into the actual details. And feel free to put your questions, comments on the chat as well. Thank you.
Sure. Thanks. Yeah. So here we deep dive into the Terraform overview. So mainly so what is exactly the Terraform? So Terraform is mainly a part of the HashiCorp DevOps tools suite, and so mainly it's using the format which is using the code is like HashiCorp language. So it's like it's a declarative language. So it describes like the end state in the high level syntax, right? Which you can share and reuse. And it's based on the Go language. So underneath layer. So that's the format it is using. And so mainly the open source tool which you can use it to build your infrastructure or change or version control or the code and across like multiple providers, right? So when I say providers, so Terraform has a provider for each and every public cloud and private cloud infrastructure, right? So mainly like for VMware, we have the vSphere and NSX-T and vRise Automation, VRA. And on the AWS side, there's others from AWS and other public cloud, Azure, Google, IBM software, right? So there are various providers out there. So you utilize those providers in combinations and you can deploy or stand up your whole infrastructure using those providers, right? So these are call it as like a endpoints, right? So we call it as endpoints. That's the right way to call it, the providers. And then so this is like a client-only architecture, so that where you don't need to install any binaries or so like no need to install any agents, or not binaries, any agents or maintain or build any dedicated server to manage those like Puppet or Ansible, right? So it's just a client-only architecture. So it's really a simple piece of code. You install the binaries and use the piece of code, and you should be good to go on the Terraform side. And so we have the various execution plans, like we're planning the phase where you, when you do the, before deploying it, you plan it, and that will show you like, so what the end state of your whole infrastructure system is going to be. And based on that, you can modify your HCL code, HashiCorp language, the declarative language based on that. So we call it as like a main.tf file, so which I'm going to explain it in the further coming slide. So it's very easy during the planning phase. You can see what are the changes going to be happen. So like a dry run, and then that'll give you like whether it's going to be modify changes or adding some changes or destroying or deleting some changes, right? And then and those are the various plans you go through, like each and every stage. Like you plan it and you deploy it and you validate and check, and then once you're done, you destroy it and the environment. Yeah. And when you come to the resource graph, so each resources when you in the Terraform provider, using provider, you're going to provision those resources. Like for VM provisioning in vSphere, we're going to provision the VMs, and we're provision the network, data store, and all those resources get provisioned for building a VM in a vSphere, right? So same goes for the NSX-T, like the logical router and the logical switch. So all these resources are, or having dependencies on each other. So there's resource graph that maps all the resources and keep the dependencies. So this one I'm going to deep dive into the forthcoming slide with an example, live example, so you can get an idea of it. Okay? So that's why that keeps the state of what already deployed. So when you already deployed and it keeps the state of it, and then when you try to redeploy it, it gives an option like, so there is nothing to change. Or if you modify any changes to the configuration, it'll based on the state of the system, it will say like, okay, these are the changes we're going to modify or going to add, right? So that's the state of changes maintains that stage throughout the end-to-end process for the automation. So that's why we call like the state of what's already deployed and apply changes only needed. That's what we call it as like ADAM potency. So the keyword we are using it here. And so mainly the whole Terraform is like a open source tool. So with a very easy to learn high level language syntax based on the Go language base. And you can utilize the Terraform for any cloud agnostic deployment across on-prem or off-prem. And so that's the overall view. Yeah. Any other questions before I move into the next slide? Yeah. And so here when we say the vSphere and NSX-T Terraform Provider, so this is how the provider interaction model works. So mainly we have configuration file, so the Terraform that manages it. So that utilizes the provider. So that comes from our VMware, and it was supported by the HashiCorp. So that's built by VMware and supported and certified by HashiCorp. And that's underneath the layer is using the Golang SDK. So that is, which is auto-generated by Swagger tool, CodeGen. So that communicates with all the APIs internally integrated with vSphere and NSX-T. The same applies for all other public clouds and everything. So this is how the provider engine works, right? So mainly the whole understanding of this provider is like having the API interaction with underlying infrastructure for vSphere, NSX, or public cloud. Right? So it's all using the CRUD operations resource, and it will create various resources or interlinked together, decoupled. It's all infrastructure components like virtual machines or clusters or folders or what you name it, right? On the vSphere side or NSX side, logic switch or logic router or NAT rules or firewall rules. Yeah, and so all these providers, like, they're all open source and it's all supported by VMware. So any issues or anything, you can always open a support case. Yeah. So let's move on to the next slide. And so here, why Terraform, right? So the Terraform, we're using stateful architecture of the Terraform. It's like avoiding the config drift. Okay, so I'm giving a two piece of code, right? So comparing with the other configuration management tool like Ansible code. So here in this code, I'm going to deploy an instance, a release instance, which has a count number 5. So this code is going to deploy, Terraform is going to deploy 5 instance, and same Ansible is going to deploy the 5 instance. Okay, so pretty good, right? Yeah. So we go to the next. I'm going to show you, like, if I change it, the count to 10, right? So the difference here, what it's going to do is the Terraform is, if you guys have any answer, please feel free to chime in. Like, so what it's going to do. So these two changes, what's going to do, the Terraform is going to do. Right now, any idea? So I already deployed 5 VMs, and now I changed the count to 10 in both the codes. So what do you guys think? So will it provision 10 VMs or it will go into provision 15 VMs? Okay, so I'll keep the silence. So this code, particular Terraform code, so when I say like code 10, like I said earlier, it has a stateful information of the current state. So you already deployed a count of 5 instance. So it's only going to deploy extra 5 to make it to 10 count because it has the stateful information. But when it comes to the Ansible, this is going to deploy another 10 count of another 10 instance. So it will be 15 instance, right? So this is the key beauty and difference between the other configuration tool, right? So it always reads the state of the infrastructure, like how many instances are installed already. If it is already installed 5, or if it is 6 or 8, based on that, it will only reduce provision up to the count which is you're applying it for. If it is, so if you're already 5, then if it is 10, it will be going to deploy only 5. Okay. And also, like, the Ansible code or other puppets, you can do it the same thing what Terraform is doing, but you have to add extra code and changes to it. you have to use the combination of exact count, and then you have to tag it, the parameter, and modify, right? So you have to modify extra stages. So what I'm trying to say is, like, this is all out of the box. You have the state of your infrastructure, everything instead is already there and maintained. So let's move to the next one. So the dependency map, which I explained earlier, the graph of all the resources. So in this example, I'm just showing the code, right? So this is a simple code which deploys the AWS instance. So here we have the VPC network, and then after the code, we are it's deploying the subnet, and then it deploys the internet, the router, everything, right? What if I move this subnet router, right? This particular code, the subnet router, which I move it to before this line, right? But still it provision everything intact. It won't provision in the sequence, because even if you install the sequence, when you change the sequence, it has the dependency mapping. So you don't need to worry about the resources has to be lined up accordingly in the sequence order to provision those dependencies, right? So you don't need to worry about those. If it is an Ansible, yes, you have to be in the configuration, you have to see in the sequence in the code, but here you don't need to worry about the sequence or anything. You can add this piece of code in before that entries here or anywhere. So it maintains the dependencies mapping perfectly all right. Yeah. So other things why we need Terraform, so mainly automating all your infrastructure, obviously. Yeah. So your vSphere, your environment, your networking, firewall configurations, and make sure, like, we independently manage the data centers and ensure the consistency. It's somewhat painful in the in current environment, like where you're maintaining your multiple data centers. You have to make sure, like, you have the uniformity of configurations across the board, right? And also multi-cloud capabilities, like cloud agnostic solution, like whether it is on-prem or off-prem, and the portability of configurations portable to the other public cloud platform. And it's very easy to write templates. It's a declarative language, and we can execute these in multiple remote instances. Like when you deploy a VM, you can run this Terraform code inside the VM to execute in the remote instances, and it can work as a CI/CD pipeline along with that. Yeah, and so here comes one particular use case with the CI/CD pipeline. So where you can have the GitHub that has the code and everything pulls up. You can have the GitHub trigger. So that goes and kicks in the Jenkins jobs that has the various Terraform files to be applied and applied. So, and that has combinations of what environment you want to deploy, so dev, QA, or prod. Based on that, it makes some changes to the infrastructure on the vSphere side or NSX-T side, right? So this is the end-to-end like CI/CD we can utilize in conjunction with Terraform along with the Jenkins tools or other development CI/CD tools. Yep. We can so other tools which we can use the Terraform, where we can use the code stream. So we have CI/CD with the code stream, so you can include the Terraform along with the code stream. So here I have the GitHub repository that goes and deploys the VM blueprint. So here we have the VLI's automation to deploy VMs that you deploy the apps and everything. So we have the Terraform combinations to deploy various web app DB apps, and CodeStream will do the integrate the CodeStream pipeline will do all the UI tests using the Cypress tool is one of the UI testing tool. It's a Python based, and so do the load test, which is JavaScript based. So you do the load test using low-cost IO, and finally you release your application, right? So this is another form of like using CodeStream, the Terraform with using the CodeStream tool. Yeah. So so let's get started with the installation, right? So macOS, it's pretty easy. You install the brew.sh, and using brew install Terraform, you will install your Terraform infrastructure, right? So Terraform tool. So it's pretty easy and straightforward. And so the manual pages, like manual download, you have Terraform.io downloads. So just install the zip file and unzip it, and you're done. You have the Terraform installed. The various editor tools we use IntelliJ, Atom, or I use Visual Studio extensively. So WebStorms or other Fabric, whatever the IDE tools, you can use it. Yeah, and other things in Linux, we just use the using wget. So get it wget pointed to this particular URLs. So that's when you go to the website, often it'll give you the location of the hash graph where to download. So when it's just a simple wget command, you download the zip file, unzip it, and you have the Terraform installed. And next for the Windows, so you can download the binaries from the website, unzip these files, and configure your executables. Or other easy way is install Terraform with Chocolatey. If you have Chocolatey already installed, so you can install Chocolatey. That will just a one simple command like choco install Terraform. That will go ahead and install your Terraform in your Windows box. Yeah, and so the Terraform process flow. So we have the validate. That's where you validate, you plan everything to make sure everything's intact, and then you plan. That's where you're staging it. That's a dry run. And when you do the applies, then apply the settings and everything across the your infrastructure, right? So no matter what is vSphere or NSX or other public cloud. And show will show the actual like what's exactly was done. And when you do the destroy, you can destroy the whole environment, whatever it is based on the configuration, it will just destroy it. And moving on to the Terraform vSphere provider. So here, how you get to the provider, right? So when you go onto the URL page, Terraform page, and search for the vSphere, it will come up with this land up this page, vSphere, VMware vSphere provider. So it's, but when you click on this right corner, use provider, when you click on this, it automatically pops up this code, right? So you can just copy this code, and this is your provider. Just put it in your main.tf file, and you have your provider in place. So that's your endpoint for vSphere, right? So, yeah. So, and then the other thing is like main.tf file. So this is where you put your providers, and then you have the have your configuration, what you want to provision. You want to provision your Windows VM, so that gives all the resources you're going to provision for vSphere. So that's your main.tf file, is a main file which you can create like main.tf file for each and every environment, right? So you can have a folder structure for development, QA, and production. Underneath, you have a separate folder for dev, QA, prod, and then underneath you have different main.tf file, right? So some of the entities are specific to the QA, some of them are entries are specific to prod, some of them are for the QA prod. So you just segregate those using the foldering structure. Yeah. And once you have the main.tf file, and you have the setup provider, which I explained earlier, and then you have the variables. This is where the variables will be defined. That's in the variables.tf file. So these are the variables which you can define. What are the values and everything. And then if you go on to the next, so you can run the Terraform init. So that's where when you run it for first time, you initialize it to make sure there is any new Terraform versions of that, so to download and initialize it. Yeah. And then the next is like Terraform plan, that will see any changes to be made or anything new to add. So this will go ahead and see your environment and changes. So in this case, I'm having the new VM to be created. It checks all the resources and gives you the plan like, okay, so 1 to add, right? So 0 to change, 0 to destroy. So next, once your plan, you're satisfied with the plan. So next you run the Terraform apply. So when you say Terraform applies, it goes in and apply the changes and everything. It shows all the values, what is going to be changed, what is going to be applied in the vSphere side. It's creating a VM. And then so once you press yes, it goes and apply, and all the changes will be done. Yeah. And next one is NSX-T provider overview. So this is the same thing, like go to the Terraform website for search for the NSX Terraform. So NSX, it will provide this particular provider. So click on the use provider, it will automatically shows the code. So this is the provider you have to copy and paste in your main.tf file. And then your TF file looks like this. And so the main.tf file, so this one is like installing the NAT rules. So I'm using the files, local files, CSV file to use, and passing the CSV file, and then it applies all the entries to create the NAT rules, right? And then here it has all the variables. So I have the variables.tf. So this is where I have all the variables of NSX manager, username, password, and all those things. And then I have the input files where the CSV file to be passed. And apart from the variables.tf, I have a terraform.tf was. The tf was is the actual value of those variables, right? So in the variables you declare in variables.tf, but I have the values, everything stored for those variables in this the secure way that will keep it in the terraform.tf VAS file, right? So that's where I keep it all the values and everything. Yeah. Like I said, you can have the multiple folder structure, so where you can create folders for segregation, where you can put development, QA test, or production. So that's an easy way to have a foldering structure, so where you can know which environment you are running it for which environment, right? So let me monitor the chat section. Yeah. Okay. So, and then next is the same thing like Terraform init. So you have the initializes the Terraform to make sure all the versions are up to date, and then do the Terraform plan. So here I do the Terraform plans, modifying these changes. So 4 things to be added, and just go ahead and apply the changes. That is, go ahead and do the changes at the NSX side. Yeah, and then so Terraform apply. So once you apply it, so these are the changes get applied. So it's does all the creating the rules and so on, right? So everything is compliant. So resources for added resources. So it's just a simple piece of code, piece of mind. So when you have the automation in place, you have a spinal interface, like doing it very easily done with a single push button style from the Terraform. So it makes life easier for the BI admins. Yeah. Uh, and then, so let's go into the demo. So I'll just stop sharing this and then share my demo environment. So quickly walk through my lab. Yeah, just a second. Sharing. Share my screen. Are you able to see a screen? My desktop?
Yes, we can see it.
Yeah. Okay, so you can see that my command line, right? The Linux, the dev tools. Yeah.
Yep.
Okay, cool. Awesome. And let's see, I'll just move the window down. Okay, so let's see. So I have the folders here. So I created separate folders. So let me go to Terraform vSphere. So here, if you see here, I have all the files. So mainly I have the main.tf files. All right. So this one is what it's going to do is, so it's using the vSphere provider. So that's a provider copy and paste. So which I showed you in the previous slide. And then the resources I'm going to create is data store, and then the vSphere network, and then actual virtual machine using the template, and other resource I'm going to create is like resource pool, where I'm going to deploy. I use the resource pool, and then the compute cluster, which cluster I'm going to use. I'm using the workload 1, and so what the vision name I'm going to use is like Terraform test. And what are the resources I'm going to use, right? So mainly I'm going to use the resources are all the CPU, memory, and so on and forth, right? So most of the data it's going to use, like all the interdependent, all these networking and data stores are all interconnected, and that's the resource pool for the vSphere resource for the vSphere machine. This is the code which defines it, right? And also I'll explain how to see for the code in the within the Terraform website, right? So how to utilize those pages and write it. And so once you have this main.cf file, so this is the main.cf files, and we come further down. So you have the other resources for network, and you have the disk. So how many disks you want to add, and we're going to clone the template. So, and then you have the custom spec which you're going to use, and network interface, and IPs, and all those details. Yeah. So that consists of all your main.tf file for the vSphere particular VM creation thing. So you can have the same main.tf file. You can add extra stuff like creating a cluster, or creating a folder, or doing some network changes, or anything, you name it, right? So any we admin task, you can just add it in the main.tf file. And so once you have this TF file, so I have the variables. So here I define all the variables. If you see all this like vSphere user, vSphere password, vSphere server, this is the one I used in the provider in the main.tf file, which I was using this, which I can show you real quick back. So if you see here, this is the variables, right? Anything var dot things, those are all I'm using the variables. So whenever whatever you see var dot, it picks up the variables from the variables.tf file, right? So that's all it does when you declare it as a var dot in the main.tf file. So these are the variables I have, and then you have Terraform.tf. This is where it has all the values stored for your variables, right? So when I do the mod.tfs, so you have all the variables and values and everything, right? So we can also have it like a very secure string to not to explore the password. There's another way to do that, but I'm just giving a basic example like how we can store the values using the Terraform.tf. Okay. And so once you have this, and then you, so first thing first, when you install the Terraform and everything, so you run the Terraform init. So that'll go and initialize, make sure the latest Terraform project is all downloaded and everything. Yep. So now everything's initialized, and then now you can start with the Terraform plan. So Terraform plan. So the Terraform plan will go ahead and review the main.tf file, and then it says like what are the changes it's going to do, right? So you have all the list of files. So it's creating a virtual machine will be created. So you have all the details of all which you mentioned in the main.tf file, right? So all the details, these are things going to be added. Whatever the plus command you see, all these things will be added, right? So and then disks are added, network, and all those things. And plan 1 to add. Okay, so there is 0 to change, 0 to destroy. So now once you're satisfied with the plan, so now we can go and apply the change, right? So we'll hit and apply. So it'll again do the plan dry run, and it gives you the last chance to see if you want to proceed further or just cancel it out, right? So these are the things. What are the plus signs? It's mentioning it here. So these are things will get added. So you're comfortable with this change. So one had to be added. So before adding it, just let me log into the vSphere. So right now there is no Terraform VM here, no activities, nothing. So let me go ahead and let me go ahead and install, apply the change. So I click yes. So this will start, go ahead and do the changes, right? So it's creating a virtual machine. So now you can see here in the task window, it's doing the cloning the virtual machine. So it's still creating it. So just keep on saying it's still creating until all the resources get created. It'll keep on showing that it's creating it, right? So it's creating a reconfiguration virtual machine, customizing the guest wires, and and doing all kind of changes, right? So power on the virtual machine. So this is the machine get created. And so you have all the objects get created, and then it has to assign an IP. So let's wait for that to complete. So powering on the machine. So let's have the IP address assigned. So it'll just keep on stating they're still creating until the VM is completely created and up and running and accessible. Okay. So let's give it a few more seconds. So it's got the IP address. So now once everything is done, you can ping this IP address or connect to this IP address. Yeah. So let's see once. So Let's minimize. Okay, so it's done. So if you can ping the IP address, which is 192.168.50, so it's accessible. So that's pretty much it, right? So so once everything is done, and say for instance, if you want to destroy this machine, right? So like say, so you don't want this machine to be running, you want to clear it up. So you can say Terraform destroy, or you can say Terraform initialize. So say the Terraform destroy, so this will go ahead and destroy the VM. So you can see it'll say like, okay, one VM will get destroyed. So you can say yes. So this will go ahead and destroy the VM, which is you don't need, right? So it's initiating the shutdown and destroys the VM. So the VM is gone. Yeah. And so let's move on with the other example, which is Terraform NSX. So here I have the main.tf file. So here what I'm doing is I have the provider, right? So this is the code which I showed you in the other slide, which from the how to get this provider code from the Hashicorp website. Just copy and paste, and then I'm using this locals. That's a local file I'm using. So I'm giving the path which file to use, right? So I have this file here, CSV file that has all the NAT rules and everything. So, and then the provider NSX-T, the username, password, and all the hostname details are here in this variable file. So var dot, so that will be in the variables.tf file. And then this is the resource we're going to create, the NSX NAT rule. So these are the combinations we're going to create for in the for each loop. So I'll use this file and then create all the NAT rules, right, for NAT rule resources. So if you come here and see the variables, so here I have the variables for NSX manager, user, all the password, all those details, right? And then the Terraform keywas that has all the values and everything, right? So for the variables. So now let's do the Terraform in it. So just already initialized. So now let's just want to make sure there is no naturals in there. Okay. I have this advanced network security. So let's go and see the NAT. Virtual gateway. So this logical router I'm using. So don't have any NAT rules. Okay, it's all empty. And so let's go ahead and apply. Let's do the plan. Terraform plan. That will go ahead and read the file and say, so it's loading the CSV file, right? So so I didn't show you the CSV file. So that's the what's the CSV file? So that's the CSV file. It is reading the entries, right? So it's getting all the details from the CSV file, all the 4 NAT rules, and the plan. It's going to add the 4 NAT rules, right? So that's what it's showing, the 4 new things to be added. So these are the NAT rules getting added, right? It reads from the CSV file, gets all the data here, and these are the 4 NAT rules get added, right? So, and that's all picks up from the CSV file. So now, so let's go ahead and apply these changes. So here it's going to apply the 4 NAT rules. So if you see NAT rule 1, 2, 3, 4, and these are NAT rules split applied. And let's see S. So plan 4 to add. So it's getting added, and then now it's all applied. So now let me come here and refresh it, right? So you have all the details NAT rules created, right? So here, the one thing I want to show you, like it has the, even if I make some changes, right? Say like, for example, let's take this NAT rule first one, right? So let me go ahead and edit. Let's say make some changes, destination, let's say 335 instead of 334. Let's save it. Okay, so, and then if anyone by mistake make any changes, but you can come here and you can run the plan, it will still go ahead and apply those changes, reverted back all these changes, right? So if you see here, all the files are in the state file, right? So what it does is whenever you do the plan or apply, it will go and read this Terraform state file, right? So it goes the Terraform state, and so I have the there. So you have various environment you can create it, right? So when the prod QX, so where I have the, this is the state it reads, terraform.tf state. If you see here, that has all the entries, which is 4 NAT rules, which is created, right? So it has all the entries and details and everything, right? So here in this case, like what I have is a couple of changes I made. So you can even it reads this file entries and make sure those are make sure to validate those changes and then apply it accordingly, right? So in this case, the current state is like 334, but what I did is like I changed it here 335, right? So here the destination I may change it to 335, right? So, but what happens when I do an apply, it reads this file, the state file, that's a state configuration, and then many changes made in the current, it will validate, and then it says like, okay, I want to make some changes to be made in the current environment, right? So it knows that this natural one has to be changed, right? So let me go ahead and so let me go ahead and run the plan. So if you go run the plan, so this will go ahead and do the state file check, and it says like unchanged and one need to be changed, which means this has to change 335 to 334, right? So there's a change you have to make. Yeah. So, and then you can just do the Terraform apply, and just to go and apply the changes. It will show you like one to change, and this is the change has to be made. This one has to be changed to this one, and just your comfortable change, click S, it will go and apply the changes. And then now you can see, now you can go ahead and refresh, and then let me go ahead and edit this. You'll see it'll put back to the 334 instead of 335, right? So this way you can manage all the configuration drifts in your environment. So that's pretty easy to utilizing the Terraform to manage your configuration drift and everything, right? So that's the key idea here. Yeah. And so yeah, pretty much in the demo. So let me stop sharing this, and then let me come back to the slide deck. Yes, if you have any questions, please let me know. So feel free. Yeah. And let me share the screen. Yep. So here, so coming back, so troubleshooting, right? So how you identify the problems when you are troubleshooting, when you're running it, it's something south. So the Terraform side, like what we want to do is like find the source of failure problems, like on performing side are commonly going to show up like inability to collect data, right? So on those data sections, like where it reaches out to find out the resource and pull it in, going to fail because maybe that user or developer doesn't have the right permission to the environment or to query the data, right? So that's one area to look at it. Errors on the Terraform side will always typically show up very specifically, like I have a failure on the 118, unable to find this, on 118 line, unable to find this, right? That's usually a really good indicator that you are having an issue on the Terraform side, unless of course it's an issue on the line that it's pointing it is data collection. So then it is might be a permission issue there. Yeah. And any kind of like a crash in the Terraform will always provide a crash.log. So which is going to give you a multitude of things to look for. Essentially, like when you're looking at the crash log, if you receive one, check the last say 40 lines, because that's really where the bread and butter, the failure is going to be, right? So that's going to be like everything that was occurring, but it's also going to show you the failure of mostly at the very last section, right? So just before it's terminated. So another good tactic when you're troubleshooting is Terraform issue is similar, simplify your code. like a building block folders, right? So create a folder structures where you can know where it's exactly failing for each and every resources building blocks, the foldering your structures. Yep. And then the problem on the vSphere NSX side, so monitor, check your events and see like what's anything going on the vSphere side, infrastructure side, or NSX-T side, and review the VM deployment and see why deployment is failing. So is there any resource not available, or any issues on resource pool, or any data store is not accessible. So those kind of things, right? And then review the logs. Mainly another thing is like review the logs on the vSphere side or NSX-T side. So these are the main things, like we can do the troubleshooting on Terraform side and also on the infrastructure side, right? That applies all to the cloud agnostic solution on the public cloud as well, right? So we like automation or AWS or Azure or GCP. So we go to the next slide. So if anything you are not able to find out, so best resources like kb.vmware.com for the Terraform provider, or you can get help or find the log bundles or submit the log bundles and so on and forth to the GSS, right? To the VMS support. The other thing is like the easier, this is a hands-on lab, HOL 2121 05 CMP that has all the Terraforms, everything installed. So you can go through the lab, one of the DevOps using Terraform. That will give you the Terraform exercise, which you can play around, which is already set up for you. You can go and install. It will give you the step-by-step instructions using the HOL lab. So this is the particular lab you can use for the VLS automation for DevOps. So this will give you the one of the lab section. You don't need to go through all the labs. There is one particular item for Terraform. You can use that chapter and then go through the lab that has all the codes and everything. So we can utilize those. Yeah. And the other things, like any other questions, Tim? So before I end it, so please feel free to chime in and ask questions. Yeah, I'm ready to help you on that. Any other questions?
Feel free to unmute yourselves if you have any questions for Selva. Or post anything in the chat if you don't feel like unmuting and speaking. This is really cool to see. I've never used Terraform before. I've always been more of a PowerShell guy, but this was cool to see.
Yeah.
I need to play around with Terraform.
Yeah, definitely, Ben. So that's like I mentioned, like the lab is pretty straightforward in to utilize it. So
yeah, that's awesome that there's a lab just for this.
Yeah, I can also give that script, package it, and send it to your team, so you can share it across. I can give the scripted package, and you can use those scripts, Terraform main.tf files. So for play around, yeah. So that'll be a good start, yeah. Yeah, sure, right. Yeah, I'll do that. Yeah. So we'll send this deck and also the zip format of the scripts. Yeah.
Thank you. All right, awesome.
Yeah, sure.
Thank you very much.
Yeah, you're welcome, sir. Thanks. Thank you so much for the opportunity, Ben. And yeah.
Of course. Of course.
Sure.
All right. So just